Hello everyone, I am Sindhura. In this video, I would like to tell you about Wi-Fi 6, which is one of the recent technology in computer networks. Wi-Fi 6. Wi-Fi 6 is the Wi-Fi alias sixth generation of wireless local area networking technology, aligning with Institute of Electrical and Electronics Engineering and enabling the efficient performance of networked devices in dense environments. Wi-Fi 6 combines the freedom and high speed of wireless gigabit Ethernet with the dependability and predictability of licensed radio. For the overall improvements to the Wi-Fi 6 clients in dense environments, it is also known as high efficiency Wi-Fi. Wi-Fi 6 builds on previous Wi-Fi standard strengths while improving efficiency, flexibility, and scalability. When we compare Wi-Fi 6 with Wi-Fi 5, the efficiency and flexibility and scalability is improved. The primary goal of this standard is to improve throughput area in high density environments such as corporate offices, shopping malls, dense resident apartments, universities, and everything. Let us see the features of Wi-Fi 6. Faster speeds, OFDMA, multi-user memo, OBSS, beamforming, 1024 QAM, security, WPA3, TWT. Faster speeds. Due to the increased bandwidth provided by Wi-Fi 6, faster Wi-Fi means the faster upload and download speeds. As file size continue to grow, as to the higher data demands of streaming, higher quality video and communication, heavy online gaming. This is becoming increasingly important. Wi-Fi 6 has the maximum throughput of 9.6 Gbps across multiple channels. Wi-Fi 6 can achieve faster data transfer speeds by employing a variety of techniques, beginning with more efficient data encoding and intelligent use of wireless spectrum, which is enabled by more powerful processors. Wi-Fi 6 reduces the latency by up to 75%. This is accomplished by more efficiently handling large amounts of network traffic. This means faster game downloads, faster uploading files and downloading games and downloading files, and also upload speeds for streaming gameplay and more reliable media multitasking for gamers. Wi-Fi 6 communicates more effectively with multiple devices that require data at the same time. Means simultaneously, all the devices want to require data, and it prioritizes traffic and across those devices more efficiently. OFDMA, Orthogonal Frequency Division Multiple Access. Orthogonal frequency division multiple access is a Wi-Fi 6 feature that enables access points to serve multiple clients simultaneously. OFDMA makes it possible for users to improve spectrum utilization by sharing channel resources. OFDMA is a set of rules developed for transmission of data between more than one terminal. Any device at the end of transmission channel such as a computer or a phone over a transmission medium such as a wireless network. OFDMA is an updated version of frequency division multiplexing FDM technology that divides information packets into distinct bands carried by distinct signals. This mode of communication is a upgrade that parallels the transition of Internet service providers to Wi-Fi 6 wireless, as well as the transition of phone service providers to 4G and 5G LTE. OFDM is used in Wi-Fi 2 to 5. Let us see the differences between both of them. These are the difference between OFDM and OFDMA. OFDM, it has a packet multiple users packet per TXOP, high efficient, low voice or video delay even when congested. OFDM, the OFDM is used in Wi-Fi 2 to Wi-Fi 5. It is a one user packet per TXOP. Inefficient for small packets, high voice or video delay when network congested. Here see, multiple users, it is divided into small packets. The data is divided into small packets. When we compare the frequency and time graph of the both OFDMA and OFDM. Multi-user MIMO. Multi-user multiple input, multiple output is a significant advancement over single-user MIMO, which is commonly referred to as MIMO, multiple input, multiple output. Multiple input, multiple output technology was developed to increase the number of concurrent users that a single access point can support. Initially, this was accomplished by increasing the number of antennas on a wireless router. Multiple user MIMO was limited to downlink transmissions in Wi-Fi 5. Multi-user MIMO was developed to support situations in which multiple users are attempting to access the wireless network at the same time. Because of the nature of 802.11 protocol, users are served on a first-come, first-served basis. Multiple user MIMO, which allows multiple users to access router functions without causing congestion. Applicable to large bandwidth applications, increased capacity. Let us discuss about OBSS. OBSS means overlapping basic service sets. It is another Wi-Fi 6 feature that can improve network congestion. With older versions of Wi-Fi devices trying to connect to a network used a listen before talk process, which means they had to listen for any noise on a channel before transmitting. If there was any noise on the channel, even if it is originated from a distant network, they would have to wait until the channel was clear before transmitting in order to avoid potential interference. OBSS enables the access point to use a color in order to uniquely identify the network. If other traffic is detected on the channel, but it is not the same color of the local network, devices can ignore it and continue transmission. This can help increase reliability and improve latency. As more and more of our devices utilize Wi-Fi, this will help preserve the speed and stability of our connections. Let us discuss about beamforming. Another technology that Wi-Fi 6 improves in order to achieve faster speeds is beamforming. This futuristic sounding method of data transmission is quite simple. Rather than broadcasting data in all directions, the router detects the location of the device requesting the data and sends a more localized data stream in that direction. Let's see what is the working of beamforming. Single beams are analogs to light beams. A flashlight's beam has a predetermined shape. If another flashlight produces a light beam in the same direction, the two light beams are superimposed, increasing the brightness and changing the shape of the beam. When more flashlights are used, the brightness and shape of the superposed beam change, turning on or off the flashlight or adjusting the light intensity affects the beam shape when using multiple flashlights. Similarly, in wireless communication, an antenna like a flashlight emits radio beams. The radio beam shape can be adjusted with multiple antennas by controlling the radio signals transmitting by each antenna. Let us see about 1024 QAM. Quadrature amplitude modulation is a method of transmitting information to receive device by attaching data to radio frequency waves. QAM modulation, which is commonly found in modern radios such as wireless routers, convert digital packets into analog signal capable of wireless data transfer. It serves as language between computers to facilitate effective communication. In this diagram, we can see Wi-Fi 5 and Wi-Fi 6 QAMs. Here in Wi-Fi 5, we can see 256 QAM, which is 8 bits per symbol. When in Wi-Fi 6, we can see 1024 QAM, which 10 bits per symbol, means 25% higher capacity is increased. Now, when we compare Wi-Fi 5 with Wi-Fi 6, the security is quite increased. Like the average user is probably more concerned with speed, especially gamers, but there is no more to a wireless network. Wi-Fi 6 also promises enhanced security. WPA3 pre-shared password. If users use a weak password or passphrase, WPA and WPA2 remain vulnerable to password cracking attacks. Using the AirCrack suite, simple password brute forcing can be attempted, beginning with a four-way authentication handshake exchange during association or periodic re-authentication. To protect against intrusion, the network's SSID should not match any of the top 1000 SSIDs as downloadable rainbow tables and a plethora of common passwords have been pre-generated for them. WPA3 replaces cryptographic protocols that are vulnerable to offline analysis with protocols that require interaction with the infrastructure for each guest password, allowing the infrastructure to limit the number of guesses in real time. TWT, Target Wake Time, allows devices to determine how frequently to wake in order to send or receive data, which reduces power consumption and improves spectral efficiency. This technology enables 802.11ax deployments to deliver high quality of service to a wide range of devices with a single contention or overlap. It longer sleep cycles extends battery life up to 67% low power consumption. Additional Qualcomm technologies specific features. In this uh, in this photo, we can see how TWT works. User one, when user one uses, it's sleep when he available, and if he is not available, it again sleep. User two will check it and available time. Like this, TWT allows to determine how frequently to wake in order to send or receive data. Conclusion. Right? We can conclude that Wi-Fi 6 provides the faster speeds, better traffic prioritizations, and added security. Wi-Fi 6 is a significant step forward in wireless network technology. By Wi-Fi 6, we can upload and download speed increases, and it also provides security of data. This helps people to connect more devices with faster Wi-Fi and secure Wi-Fi. So after this, Wi-Fi 6E also introduced in that the Wi-Fi 6E is available for the users who have 5G networks. For when it comes to Wi-Fi 6, it is for the 4G and 5G network users. Thank you so much.